All right, let's begin. Good morning, everyone. Thanks for trekking all the way to the far corner of the building on the last day of the conference. Appreciate that. My name is Guy Bowerman. I'm a program manager in the SQL Server Cloud Infrastructure team. When we first heard about Windows Azure Virtual Machines a few years ago, in SQL Server engineering, we had a lot of questions. Probably top of our list was performance. There were other questions like reliability, availability, things like that, but we had a lot of questions about performance. What IOPS is it capable of? What's the throughput like? How does the I/O subsystem work? How do writes work? How do random writes work versus sequential writes? What kind of numbers can we get? What's the network bandwidth like? Is there any kind of SLA in terms of performance? What kind of variability? Basically, we were kind of annoying, and we asked a lot of questions. And what this session represents really is our learning so far. Azure VMs have been in preview for some time, and now they're GA. We've been working with various preview customers, and we've been thinking a lot about performance, and we've been learning a lot about performance. Who here has actually run SQL Server in a VM? Okay. Quite a few. In production? Okay, about, actually, fairly reasonable number. Relatively happy so far? Sorry? Okay, you've not really delved in there. Okay, I'm just happy no one threw anything at me when I asked that, so that's good. The goal of this session is to be able to answer questions like, I've got a performance problem in SQL Server running in a VM. How do I even know if it's a problem to do with the infrastructure of the VM or something else? Hopefully we'll go through some basic troubleshooting techniques to make that question fairly easy to answer. So my real goal is demystification. Make it it's just another platform to run in. Here are the basic things that you need to know. I'm going to go through, in fact, Basically, I'm going to go through some best practices, planning, monitoring, troubleshooting. That's the real summary. So let's get started. Before I do, I'm going to try and sell you a book. Hopefully, it won't be too hard a sell because it's free. Anyone actually downloaded this book or this white paper yet? Very good. This is if this session is kind of a summary of our learning so far, this is the real in-depth summary. So, performance guidance for SQL Server and Windows Azure Virtual Machines. This is our performance team. They've done a lot of work, a lot of benchmarking, a lot of work with customers, applied a lot of lessons learned. And what you'll get in this white paper that you won't get in this session, as well as the depth, is there's a whole set of scripts that you can run. There's an appendix full of useful things like that, tools to download. So it's very useful. So if you take one thing away from this session is download this white paper. It's, 40-something pages maybe. It's definitely worth the read if you're interested in SQL performance in an Azure VM. And I assume that you may be slightly since you're here. Okay, this is what we're going to cover then. I'll start with some key considerations. In other words, what do we actually care about? What are the KPIs, the key performance indicators that matter to us? What are the key characteristics of the workloads that we're interested in? Then I'll go to what do you actually need to know about Windows Azure architecture and configuration options. And then monitoring and troubleshooting, I'll kind of do that in parallel, but some of the good, useful things to monitor and some of the basic troubleshooting steps and some of the common problems that you can encounter. And then the last part of this session, I'll go through quite a few performance best practices for SQL in a VM. You're welcome to stop me and ask questions as I go along. If I start to run out of time, then maybe I'll start hurrying up. But I'll start then with what do we care about? Taking it at a very high level, I'm going to go into a few more KPIs, but at a very high level, you're running an application, you care about throughput and response time, or kind of round-trip time latency. The workloads typically deal with. I get the feeling that most of you know about SQL Server performance in an on-premise environment, so you I assume that most people know this, but basically the workloads that we're interested in, OLTP, data warehouse, and then, of course, we're interested in what about the log file as well for either of those. So for an OLTP workload, you've got a read-write mix. It's mostly reads. You've got a smaller number of rows at a time, and then consequently the I/O size, typically 8K, maybe up to 64K, mostly random. In other words, caching doesn't necessarily help if it's a lot of random reads. Usually a high number of users. For a data warehouse workload, scan intensive, you're reading a lot of data at the same time, so consequently you've got, I think a typical measurement is 164K read per 8 512K reads. So doing more sequential kind of reads. Fewer users. Now these, like the amount that you read, that becomes important as we go through and we look at the architecture and we look at the caching that you get in a VM. And then for the log file, obviously it's mostly writes. It benefits from having the lower the latency, the better. So typically you'd want to put your log on a fast disk write. So what do you do in a VM? And then tend to be highly sequential. So that's at a very high level, the type of workloads we're dealing with and what we really care about. I'll go through some characteristics, starting with the architecture. And as I go through the architecture, we'll talk a little bit about latency and variability. In fact, I'll talk about latency now. If you think in terms of disk latency, typically it's a higher latency if you're in a VM, but it's not that high. We're talking of the order of 40 milliseconds, say. What's important is how high does it get, and that's the variability. You can have, so what we look very carefully at is like the 50th percentile, the 95th percentile, and beyond. Our biggest concern, what you tend to get is you get a performance graph which is all the way up to 95th. It's still fairly low latency, and then up to 99.9, you can suddenly get a kind of a spike in latency. Our biggest concern there is that no I/O stalls. That was something we had to deal with when we first started playing with VMs in a test environment, but now we don't see any I/O stalls. I would say that the latency is pretty good, certainly up to 95th percentile and beyond. And then as we look at the architecture, what can you actually configure? What can you tweak in this environment? It's infrastructure as a service, so the hardware is provided and maintained for you, but you can make changes to the operating system, to networking. You can create a virtual network. So you've got some options there. So let's go through those characteristics. I'll start with configuration options then, but I'll kind of mention the others as I go along. Things that you can tweak, the virtual machine size. As you tweak the virtual machine size, you can tweak the network bandwidth, that you get changes in network bandwidth. You've got a few choices in where you put data, what kind of disks you put them on, and how many disks. And then you can actually make changes to the disk cache settings as well. And we have recommendations there. And one thing that's worth noting, and I might point it out again, is that our recommendations don't always stay the same. What we were saying 3 months ago may be completely different to what we've now learned. Also, the hardware improves, the service improves, so it's definitely worth keeping up with the blogs and the books online, and I've got a few references about that at the end. So let's start with the machine size then. I'm guessing that most of you have probably seen this chart of different virtual machine sizes, and when you create a virtual machine, you get this choice of different machine sizes. From small and above, you at least get a CPU core, and if you're doing work on premise, then you basically often you know what machine size you're going to need because you've maybe already done some performance characterization on premise. So because of that, you can choose what type of machine size you want to use. So number of cores, the amount of memory. You can ignore the disk space for cloud services. That's more for other virtual machines like worker roles, things like that. But the disk space for virtual machines, the amount of memory bandwidth that you get with these different machines. As you've probably seen, the virtual machine size, it used to be called like small, medium, large, extra large, kind of run out of adjectives after that. We could call it ludicrous size or something like that, but we're just starting to number them now. So, and then you can attach data disks, and they can be 1 terabyte each. And then, depending on the VM size, you can attach more data disks. And then the maximum IOPS. So each disk is capable of at least 500 IOPS. We've actually seen more in testing, but this is what it's safe to say you can expect at least 500 or more. So then the maximum theoretical IOPS is if you've got 16 disks, 16 times 500 IOPS. So there's some theoretical 8,000 IOPS. We'll see how that pans out when we start looking at what happens if you stripe data across multiple disks. Any questions about the VM sizes? Okay. Let's start talking about I/O then. So it's an interesting characteristics, the I/O. The disks, it's implemented as a shared multi-tenant service. There's some great things about using this. You've got built-in triple redundancy, and you've got optional geo-redundancy. And this is backed by an SLA, so you've got a very reliable service. But then, as I mentioned, the performance can be less predictable because there's other things going on. You've got host machines, storage services, network bandwidth. It's all shared between subscribers. So the performance then, it depends on when and where the VM is provisioned. There can be maintenance operations behind the scenes, so you can get that little amount of variability. But it's, as I said, it's not too bad. And then you've got other good things. You've got granular control of configurability versus cost. It's simple. Out of the box, it's redundant. I've got a couple of diagrams here just to kind of illustrate. As far as the VM is concerned, it's really just, let's see if I've got a mouse on this. As far as the VM is concerned, it's just dealing with an OS and a disk. But then behind the scenes, you've got the storage service. And what happens here is partitions can get dynamically balanced just to be the most efficient. That's normally good, but then if you haven't accessed your disk for 20 minutes, things can actually slow down because there may be a rebalancing operation taking place. And until you've done some disk activity for a while, it then gets faster again. So we call that the warm-up time. So if you actually want to get consistent measurements, make sure you've actually been actively doing some work on the disk before you take those measurements. So things like warm-up time is definitely worth keeping in mind. And I'll mention that again towards the end of the session. That's why I'm kind of covering the layers that a storage request will go through. It goes through this load balancer, the storage location service, kind of to say which storage stamp is the data actually in. It goes through a partition layer where if you've got geo-replication enabled, that's where the data will get replicated as well. And ultimately, it goes down to the disks itself in the storage stamp. So that's the I/O subsystem. We're at the disk types then. So if you just start a VM, you basically get 2 disk types. You get your OS disk and your data disk. Then you can attach disks. The OS disk and these data disks that you attach, they're basically backed by Windows Azure page blobs. Your temporary local disk is actually backed by a physical disk on the host. So let's start from the top. The OS disk, it's now a dynamic 127 GB disk. So it's like a dynamic VHD if you're familiar with Hyper-V. It's optimized specifically for OS access patterns. The data disk, this is what you attach to a VM and typically where you put your data, where you put your database, up to 1 terabyte in size. Again, it's backed by an Azure blob. You can have up to 16 of these for extra large VMs and above. And then your temporary disk, this is your D drive in a VM. If your machine reboots, you can lose what's on it. So it's just for transient temporary data storage. And these are hosted and attached disks on the physical host. The problem with that is these attached disks are shared between other VMs on the host. So because of that, if you do keep data in the temp drive, it can be much more variable. So This is something we used to recommend. Put your tempDB in one of these temp drives. And now, after a bit of learning, a bit of testing, and also some improvement in performance in the other disks, we now say, don't ever do that ever, and forget we ever said to do that. So that's just one of the things we've been learning as we go along. So generally, yes, we don't recommend using the temp drive, the D drive, unless it really is throwaway data. Let's get on to disk caching. So you have a few choices on disk caching. There's basically 2 levels of cache. And your virtual machine data is basically cached inside the physical host machine, and it can be in the physical host memory, or it can be on the physical host disk. So it can be very useful because it can reduce disk I/O latency. It can reduce the number of transactions, which can then save you some cost. So you've got this reserved cache space for the VM OS disk, and then you've got data disks. They also have their cache, and it's based on the VM size, and it is hosted on the host machine. So what does that mean? What can you actually set? What can you change? So the default settings, well, firstly, the types of cache that you can have. There's a read-only cache, so all requests are cached for future reads, but the writes get persisted directly to Windows Azure storage. And then the read-write cache, which is that you get on the OS disk by default, then reads and writes are cached for future reads. And then regular writes just go to the cache, but if you specify a write-through flag or a forced unit access flag when you're doing the write, then it gets committed directly to storage. Or you can have none. So the cache is bypassed altogether, and then all disk transfers are persisted to Windows Azure storage. I'm going to, as we get to best practices, I'm going to make some recommendations of what we specifically recommend for data. It used to be, don't use cache. Now it's a little bit more nuanced than that. And it may actually depend on the size of your data and other things. So I'll go through what we really recommend is the best setting for cache. But in terms of what the defaults are and what you can change, on the OS disk, the default is read-write cache, but you can set it to just read-only. You can't switch it off altogether. If you have a data disk, it's interesting to note that the caching is supported only up to 4 data disks. So if you're using 16, you can choose which 4 to enable caching on. But the default mode for a data disk is no caching. And then it's not really relevant for the temporary disk because it's implemented using the local attached storage. Does that make sense? So keep this in mind. I'm going to kind of keeping most of the best practices towards the end once we go through the architecture, the monitoring, and the troubleshooting. So let's start with monitoring then. Talk about a few of the key tools. I'm mostly concentrating on the tools that we've used in SQL Server engineering that we find very useful. And then I'll mention Windows Azure Storage Analytics if you want to get really deep into what's happening in your Azure storage. And then going up a level, just the basics like what you can see on the VM dashboard, and then some of the performance counters, the perfmon counters that we found to be particularly useful. Key tools. Anyone used SQL I/O before? So yeah, a few people then have gone into the I/O subsystem performance at some level. It works just great in Windows Azure in a VM environment. We actually use it all the time because it's just a very quick and direct way of asking the question, how will this I/O pattern, how will an OLTP I/O pattern work in this environment, and then getting a quick answer. I've got a link there to download the tool. Also at the end, I've got some links to... There's a really good white paper that was published fairly recently on analyzing the I/O subsystem for SQL Server. So this wasn't specifically for Azure, but it's just great at showing you what kind of things that you can do with SQL I/O. I've just given a couple of examples there of testing random 8K reads, testing at random 8K writes with like a 300-second or a 5-minute run. And the param.txt file is basically where you put what to actually run and test. And playing with the wrong mouse. The other tool that we probably use the most, and I'm sure you do as well, is the DMVs. I'll highlight some of the key DMVs that we find useful when analyzing SQL Server in this environment. And I'm guessing you're probably going to be familiar with most, if not all of them. So these are the ones we tend to query the most when we're just trying to analyze this performance, trying to understand it, particularly DMOS weight stats. Do you guys, who uses that? Who reads that? I find it's a really great first point. If you think, oh, my performance is going slow, there's all sorts of traditional things to go through, like the query plan and things like that. But if as far as you know, your application is tuned, or even if it isn't, if things are going slowly, this is a great place to look and see where most of the weighting is taking place. And there's some great articles available which go into what are some of the main weight types to look for and what that's an indication of. And I'll mention a few of them. It looks like here there's a lot of page latches. Maybe there's a file that could be actually spread out a bit. Maybe there's some workloads that are trying to access, different workloads are trying to access the same file in this case. Another very useful one is the sysdm exec query stats, where for every query in the cache plan, you have one row. It's a really good way to figure out what are the top resource consumers and just understand what's happening with the query execution and how efficient it is. Another one, particularly when we're interested in the I/O subsystem, is the DM/IO virtual file stats. That one we look at a lot, and I think I have a separate slide for that one as well, because it's very useful. And then execution requests, this is more of you get a snapshot, and it's a great way to see what's blocking. There's kind of blocking transactions that are happening due to there's queries running that are contending for different resources. And then in a similar vein, particularly like for memory resources where you've got spin locks happening, that can be a great thing to look at and understand is the DMOS spin lock stats. So I'll use one or two of these as I go along. But I mentioned the sysdm/IO virtual file stats. Here's a little bit more detailed breakdown of this. Hopefully the writing's big enough. These are just really things that, if you think back to the beginning, and I said what things are we interested in, what do we care about? A lot of these things you can actually get information on if you query sysdm/IO virtual file stats. So things like IOPS, it measures disk reads per second, disk writes per second. Latency, you've got the average disk read, average disk write time. The block size, what kind of workload are we running? You've got that too with average disk bytes read, average disk bytes written. And then what about what's outstanding? What's the queue length of this? How efficient is this application? How much work is going on? So the number of outstanding or waiting IOPS, again, really, really useful to understand your application's I/O pattern. And then the throughput, aggregate throughput, very useful to know just the total disk throughput. So you can get this in the disk read bytes per second, disk write bytes per second. So just querying one table when you've got a test workload running, you can actually get a lot of the information that we're concerned about in this environment. I mentioned you can go deeper into the storage layer itself. Anyone played with the storage analytics metrics? This is, you can actually enable it in the portal, or you can use it with the REST API. But here you can just enable the minimal setting. It does have a pricing impact because it's doing transactions. If you just set the minimal setting, then it creates an Azure table for you and starts recording some pretty useful information like the number of I/O requests, total ingress, egress, the average end-to-end latency, server latency, the number of failures by category. And then you can access this table that it creates. So you can use like REST APIs. There's some tools available that you can do as well. If you enable verbose, then you get that information for every call rather than aggregated. And of course, then you're potentially paying more for transaction costs as well. So you can enable it in the portal, or you can use the set blob service properties REST API. And you set a retention policy. How long do I keep this data for? How many days? So there's some useful blog articles. I've included a link there to help you get started on that. Again, that's going really deep. There's a lot of higher level information that you can get just with the tools like SQL.io with the DMVs. But if you really want to analyze and get to a low level of understanding of what's happening, then it's good that the storage analytics metrics are at least available. At a higher level is the performance charts. Here's my machine. I'm guessing you probably see these because these are kind of in your face in the dashboard when you go and check your VM. Very useful high level. You can just see, you can see at a glance my CPU percentage. I'm obviously not doing anything with this VM, but it's good if you just see it at a glance. If something spikes, it readjusts. You can define, let's see, you can define how long this graph represents. You can choose which of these to monitor. And then if you go into monitor, here's where I hope my network is working. And if it takes more than a few seconds, I guess I'm going to come back to it. Oh, there it is. So I think what I wanted there was configure. Yeah, here's where, let's see, I think it was actually in monitor. Oh yeah, add metrics, that's what I was looking for. So you can go and choose which metrics to add. So let's switch back. And then perfmon counters. We use SQL Server perfmon quite a lot, and there's really about 8 SQL key performance indicators that we tend to be most interested in. So there's in all cases, the maximum and also the average. So there's the processor time, SQL Server processor time, and then the total processor time for the machine. The batch requests per second, and then pretty much all the logical disk activity. They're the main things that we track. If you have a web application as well, and sometimes it's very useful to, in some cases, it's useful to actually have a web application on the same machine. Normally, that would be a fairly bad idea from a performance advice perspective. But if your bottleneck ends up being network bandwidth and communication between different layers, sometimes to reduce that, if you find that that's your bottleneck, it can actually be useful to reduce that. So either way, if you've got a VM where you're running the web application, then these are the typical, I won't go through all of them, but these are the typical web application KPIs we like to measure. And of course, your application itself, where you may need to take care of your own monitoring, but these are the typical metrics if we're running an application that we try and keep track of. Number of users, execution time, number of web services, the ramp-up period, how you're testing, start and end time. Am I missing anything really fundamental here? I'm kind of suspect I am when I'm throwing these KPIs at a room full of SQL performance people. But these are the main ones anyway that we tend to measure. All right. So with the monitoring in mind, and I kind of the troubleshooting will reach back into some of that, but I'm kind of dividing this into classic performance factors. In other words, performance issues, it doesn't matter what you're running on it. These are issues that you have to deal with, and they aren't really the subject of this session. So I'm not going to spend much time on them. I'll just really just kind of highlight what some of the classic ones are. And then what are the high-level troubleshooting steps? And then some of the common issues that we encounter running SQL Server in virtual machines. The classic performance factors then. If you can eliminate these before you even start worrying about your environment, then great. Things like, yeah, you change an index and performance changes. Things like that, just the classic kind of query plan. There's a lot of good information out there. Never assume that it's going to be something specifically to do with the environment that you're in unless you've actually gone through the basic, you ruled out all the standard SQL Server performance tuning. I suspect actually there's a lot of expertise in this room on the basic classic performance troubleshooting, the software hardware configuration, figuring out locking and latching, blocking those page latches, just the standard multi-user operations, that all the same things apply, checkpoints, system operations, just understanding where to look for them, which DMVs to check, obviously looking at the SQL Server error log, all of these classic performance factors. Go through them generally first. So the high-level troubleshooting steps then. I mentioned all those KPIs earlier, like perfmon counters, things like that. For a specific application, it's usually worth just picking 4 or 5 of those that are really relevant to this application. So define what's useful to monitor, and then track it over time. In other words, start with a baseline, track a delta as these things change. Because things do change. Your workload increases. Maybe other things change as well. We run a lot of performance canaries in-house. We just run them in all the data centers. They're doing SQL Server stuff. Because we want to know what's happening over time. If there's any change in the kind of performance you get with Windows as you're running SQL Server over time, we want to know first, before anyone calls us and says, performance is rubbish today, or thank you, performance is great. We'd really like to know that first. So we do that an awful lot. We graph, we chart, we measure. We have a set of key workloads that we run again and again, and we take a lot of measurements, and we talk about them every week. Because this, particularly as the service is just starting up, it matters a lot for us to just make sure everything's behaving as we expect it to. And if there's anything that we're concerned about, we can push in the right direction, and we know it first. And then monitor so understand those trends, and then monitor the DMVs to just basically understand about the resource contentions and weights. Because that's typically, it may be a classic methodology, but that's typically where you're going to see issues. And I'll illustrate that with some common examples. So 3 issues that fairly common in a VM. They may be fairly common generally, but particularly running in a VM, depending on how you've configured it. Let's suppose your performance is running slow and you don't actually know at this point what the issue is. If it was something like CPU starting to reach maximum capacity, you might, if you were looking at those weight stats that we mentioned in the earlier DMV, you may see things like a lot of SOS scheduler yield weights. These might start going up. And obviously, you could be monitoring you could check the percent processor time, and you could actually see that. And then if you found that it was to do with CPU being close to capacity, if you're using less than 8 cores, then you've got the option of increasing the VM instance size. Otherwise, you could just identify what are the top consuming queries and then see if you can tune for that. Or do some load balancing. Move your database to another instance if you've got multiple databases and that seems to be the problem. I mean, obviously, it's real common sense stuff, but often just identifying the measurement in the first place to quickly get to that point to know what to do. I/O capacity limits. If you've got a very, very busy, a very I/O-intensive application, we mentioned all of those average disk reads, disk writes per second that are very useful to monitor. Also in the weight stats, page I/O, latch, weights, there's often a good indication. And then the perfmon counter, page life expectancy, if that starts going down, if you say that's going under 300 seconds, for example, it starts getting lower, then you may know that I/O is reaching capacity limits. Or maybe the latency has started increasing. And again, these measurements should help you there. So yeah, check the page life expectancy counter. May give you an indication. It may even indicate that there's memory pressure, which we'll get to next. Otherwise, identify the database and log files that have the I/O bottleneck. So if you can relate that back to particular files, maybe there's things you can do, like add more disks and separate data files. Adding more disks can make a lot of difference, and I'll go through some numbers of what that looks like for different workloads. Maybe you can just tune the queries. Maybe you can go back to the classic mechanisms to reduce the amount of I/O. Another option, which is great in this environment, is compression, data compression. That can make a lot of difference just because you're in an environment with a slightly higher I/O latency. So if you can just reduce that I/O with compression, you can potentially save money too with just fewer transactions to the storage system. So I'll give some examples of what we've observed in doing that. What about if it's memory resource pressure? Then there's some fairly obvious counters like memory available bytes, pages per second. Pages per second will start going up. Of course, it could be that just someone's reading a large file into memory, but as an example, again, the page life expectancy going down. You can be monitoring the process working set. And then those wait stats. You may be seeing resource semaphore waits. So things like checking the max server memory setting, that is probably not going to be that simple. You could use a high memory instance because just around the time of GA, we announced those high memory instances, the A6, A7, that go up to 56 GB of memory. So maybe you can just use an instance with more memory. Other than that, then you need to identify the SQL Server component. Perhaps you've got some CLR functions running that are particularly wasteful in memory. Perhaps there's some specific reason that you can optimize, and maybe there's some tuning that you can do there. So, like I say, if you just divide it into 3 really common issues, this is typically what we've seen. I will say, though, that during our preview, we were concerned what kind of performance problems people are going to run into. We didn't actually see many. I would say most of it was the classic performance tuning, rather than anything particularly about this environment that caused a problem. Has that been your experience for those of you that have tried running in test and production? Yeah, so I think that's generally a good sign that this is ready for production, this kind of environment. Right then, and now I'll get to best practices. So these are just accumulation of some of these learnings. And if you take everything into account that I've just said, particularly about the architecture, then this is what we've concluded, and based on our testing as well, this is what we think the best practices are. And I'm dividing this into network, disk configuration, placement of tempDB, and then just optimizing I/O. In other words, just seeing what we can do to reduce I/O. Starting with network performance. Network latency can be higher. That's a nice way of saying that you are dealing with network latency. Just because you're in a virtualized environment, there's security, there's different layers of the stack that you're going through. There's load balancing operations. Then, of course, there's even your proximity. I mean, if you've got components which aren't all in the same data center, for example, or you've got components on premise, you've got a hybrid environment, you're dealing with the speed of light as well. So there's various factors that could make you wish you had better network latency. We found some examples where if you just look at the architecture of your system, you can identify chatty application layers and consolidate them on the same machine. If you can do that, particularly if network latency is your bottleneck, then that can have a huge benefit. I think in this example, we basically just we had a remote cache. In other words, we had kind of an extra layer, and then we just collapsed it to have basically 3 web servers and the cache on the same machine. And we found that like the average execution time for like the ASP.NET operations went down. For the web server processor time stayed pretty much the same, and the request to second stayed pretty much the same. But it made a big difference. It was very useful, really, to just just identify the most chatty layer and just put it consolidated on one machine. Another option, if you've got multiple cloud services as you're deploying your application, if you can host them in the same cloud service, then communication between different apps, they communicate via internal IP addresses, or DIPs as we call them. So that means that the network latency goes much lower. So if we can just have the Azure virtual net, also you can create a virtual network for VMs. So then if you are using different cloud services, if you create your own virtual network, then that's going to perform better as well. Also, you can do load balancing of multiple VMs in the same service. So, depending on your architecture, but if you can make use of the Windows Azure load balancing as well, again, you can definitely just mitigate any issues with network latency just by balancing your load between different machines, if that suits your application. Okay, I'll talk about the configuration if you're using a single data disk. So you've attached one data disk, for example. We generally recommend this if you have less than a terabyte of data. And yeah, it provides acceptable performance. I've given some typical examples there. A nice thing about it is it's really simple to manage, and it's a very simple recovery as well. So here's some sample SQL.io measurement tests for a single disk. And what we tend to find is random I/O, yeah, 500 IOPS. We've been measuring 1,000 as well, but this is what we kind of guaranteed per disk. And then a bandwidth of like 4 megabytes a second. If you've got more of a data warehouse workload, so you've got like the 64K reads, IOPS for reads is about the same. Writes goes down a little bit, but your bandwidth increases linearly, pretty much, just because of those both reads and writes. And then for larger, you kind of get up to a limit for both reads and writes of 70 megabytes a second, in this case for a single disk. What about if you have multiple disks? So if you've got more than a terabyte, or you just need a higher level of IOPS than this 500 per disk, then you can consider having multiple disks. But how do you do that? Do you use SQL Server file groups to spread out the files across different disks? Or do you create an OS volume on multiple data disks? Which one works better? And then if you do create an OS volume, should you just use a standard OS striped volume, or should you use Windows Server 2012 storage spaces? What's most efficient? I'll start with if you use the OS striping, definitely storage spaces are recommended over OS striped volumes. So if you can use Windows Server 2012, definitely get better performance with storage spaces. And then Windows Server 2012 R2, it gets even better with storage spaces because of the way it can manage extra fast storage in a storage space. So, but I'm going to concentrate on database files and file groups because we found it's way faster significantly faster than OS striping. So I think I mentioned that somewhere, but in case I don't, definitely use database files and file groups to spread out your load if you want to use multiple disks. Choose that over the OS striping. Now, I'm not going to go through all of these measurement samples. I'll leave that to read at your leisure. I'll just summarize what we can conclude from this. So here's some measurement samples taken from spreading the data over 4 disks, spreading it over 8 disks, and spreading it over 16 disks. And then we've got those same measurements of random I/O, reads and writes, sequential I/O for 64K and sequential I/O for 256K. If I was to just summarize this, I would say that you get really good write bandwidth up to close to 600 megabytes a second. So we've just found the write performance is just really good. If you look at the writes all the way through, generally they go up more or less linearly as you increase the number of disks and you increase the load. Reads don't fare so well. The random I/O type reads, they actually do increase quite well as well. But then if you look at the sequential I/O reads, they don't increase so much. So to the point that if you've got a data warehouse workload and you're mostly doing reads, you don't really get much of an advantage by using file groups and spreading your load across multiple disks. Everything else, though, you can. So if you really want to maximize the bandwidth and IOPS, it's worth taking a look at this and then keeping that in mind when you're actually doing configuration. Should TempDB go on D drive? The reason I have a slide for this is because a few months ago we were saying it's a good idea to put TempDB on D drive. And now we're kind of eating our hat, or whatever the expression is, because it's not such a good idea. I mean, it's not that bad, but we've just found with performance now, there's really two things. One, even if it's on the OS disk or on a data disk, it works just as well. The other thing, it's more predictable. Because I mentioned that if you're using that D drive, you're actually sharing that drive with the other VMs on the host machine. It doesn't go all the way to the cloud storage layer, but that's not necessarily a good thing because you're then having to share that disk. So the performance can go a bit up and down, which is really not what you want. It's much better to have just a flatter line there with the performance. The other thing, of course, it has a configuration overhead. Because if the VM goes down, obviously you lose your TempDB. And how do you actually write to the root folder of the D drive? You need to have the right admin rights as well, unless you have some process that starts and creates a subfolder in your D drive when you start up. It gets a bit messy and complicated. So it's much better to just say, don't do it. So really, we recommend keep it on the OS drive or put it in a data drive. And let's see, do I have a demo here? Let's try and do a demo. This is a demo about TempDB placement. How am I doing for time? I tend to talk quite quickly, so I've still got lots of time. So I'm going to go into a VM. I'm hoping that my network is functioning nicely. Now what I have here is I have a workload that creates lots of temporary tables, lots of temp tables, and it uses TVP. Anyone can tell me what TVP is? Table value parameters. And it does this because it wants to basically create a situation where there's a lot of PFS page latch contention. The PFS in a data file is your page free space page. So if lots of things are using the same data file, you can start getting contention for that page. So there's going to be a lot of TempDB allocations in this workload, and we're going to see contention for that space, so we can see what to do about it. So I probably should have already started this workload, but I'll start it now. And it doesn't matter what it's you don't really get to see what it's doing. It's just ramping up. What we'll do, though, is we'll monitor what's happening in SSMS. Let's see if I maybe can increase the size of that. So what and I may increase the whole screen size as well. So what I can do is maybe look at our sysdm OS wait stats, for example. So let's take a look at what's happening there. And I'll just run. And let's see. So I'm going to just do a query on the DMOS wait stats. I'm just going to see what kind of waiting tasks there are. Interestingly, there are some page latch weights up there quite high. So that may be an indication that there is a contention for a specific page. Something else I can do is do a query on, this is a DMV I didn't mention, but it's also quite useful. DMOS waiting tasks. So let's see what's waiting to run. If I do this, then again, I'm seeing lots of page latches. And I can actually, if I scroll right and zoom in again, there's a resource description. The resource description is 211. If you searched for this, you'd see that this is actually the resource for this PFS page. So just by querying this DMV, you could actually zoom in and figure out exactly where there's contention, where there's a lot of waiting. So I'm running this workload that's really putting stress on the tempdb file, and then I'm seeing this type of contention. So I'll just kill this workload, and I'm going to run a script that splits the tempdb. Now, in this case, I don't actually need all those IOPS from lots of disks. This is actually, in a sense, it's more of a classic problem. I just need to split the tempdb up a little bit. So I'm going to add more tempdb files with this script. In fact, before I do, I'm also going to look at the kind of zoom in a bit. One thing I didn't mention, it's all very well to see waits, but it doesn't really matter if you're performing fine. So I should actually run perfmon and look at batch requests per second. I'm around 200, and I've got like 29. I'm not sure what the units are. So basically 29 disk read writes per second. So this is what I'm getting with this current workload. So let me run this. Let me kill the workload, and then run the script to basically split up the tempdb. And notice in this case, my tempdb is on the OS drive. That's fine. That's fine in this example. So I think I ran it. So let's go and restart that workload. Now, if I restart this workload, I see way higher disk reads, batch requests. I know I must have done something right, because the performance is much better now, significantly better just by splitting up that tempdb file. Let's go and maybe run that same query again to look at what the weights are like now. So if I do the sysdm OS waiting tasks, now there's various things, but I'm not seeing that page latch contention anymore. So I'm getting much better performance. So that's really just a case of things are going slow. In this case, it just turned out to be a configuration issue that I was able to resolve it. All right, I talked about caching and why there is caching, what the caching looks like under the hood. Let's talk about then what are the best practices for caching. So for the OS disk, the default is read-write, which is good. It reduces the read latency for I/O-intensive workloads, particularly for smaller databases, less than 10 GB in size. And that's to do with the size of the cache, the typical size of the cache for this 127 gigabyte OS drive. So if the working set can basically fit into the disk cache or memory, then you can reduce I/O, and you can just leave it as the default for the OS. And that's why it is nuanced depending on the size of your data and the type of workload. For data disks, definitely if you've got databases more than 10 GB in size, put them on data disks instead of the OS drive. And then the cache settings, it depends. The default of none. If you've got a lot of random IOs, like an OLTP, where the cache is less use anyway, then pick the default of none for the data drive. That way, you just it maximizes the I/O rate. It goes past the physical hosts and disks. Of course, then you're paying more for your transactions, but the transaction as a total cost isn't that high. And then if you've got read-heavy workloads that are sensitive to latency, then it's worth enabling the read cache on the data drive. So that's the basic best practices. We go into that in a little bit more detail in the performance white paper if you want to get more into that. But at a high level, it's that straightforward. You can set the cache actually even in the portal. Obviously you can do it with the REST API and with PowerShell, but you can do it in the portal as well. When you add a disk to a virtual machine, you've got a choice. In this case, it's a data drive, so you've got a choice of none, read-only, read-write. I mentioned data compression. Here are some examples of some I/O-intensive workloads. The first one is a data warehouse type workload where you're doing lots of sequential reads. explain how to read this. This is with no compression. This is with page compression. And then you've got CPU time. It goes up because it's doing work to do the compression and uncompression. But your physical reads goes right down. Your logical reads goes right down. And in this case, the elapsed time went right down. There's more details on what the test was. This is actually taken from the white paper. There's more details on the mechanics of this test. But it definitely made a huge difference for a data warehouse type workload. Similarly, with an OLTP workload, here we're measuring throughput and CPU time. The throughput went up from about, we've got here 30 business transactions per second up to 60. CPU time, it increased, but not about 50%. Obviously, if you had a CPU-intensive workload, you probably don't want to do this. But for I/O-intensive workloads, generally, it's a really good idea. So, but of course, do those testing, use those test tools and actually measure this and determine if it's worthwhile. It will help you with the actual storage transaction costs either way. Another thing is instant file initialization. Who here uses instant file initialization on premise? One. I suspect maybe more, but maybe you might call it different things. I'll give an example of it. In fact, why don't I give an example of it and then talk about it? So if I go back to my VM and I run secpol.msc, I'm going to go to the right place and then zoom it. So I'm going to go into security settings, local policies, user rights assignments, and then perform volume maintenance tasks. So let's zoom in a bit here. It looks like I've already set this, or at least someone's already set this on this VM, because the perform volume maintenance tasks, it looks like NT Service MS SQL Server has this right. If you set this right, and then you'll need to restart SQL Server because it's a security policy setting. So why do we want to do this? Let's take a look. As I said, it's not default in an Azure virtual machine, so it's not on by default, but it's really good. We've particularly seen it. Let's suppose you're doing a big restore in the cloud, like multi-terabyte kind of restore. It can take hours. You can massively reduce it by setting this value because it doesn't have to go and do all of that, initializing the whole file and then writing to the whole file. So in that sense, it's well worth setting. Also, though, for creating a database, adding files to a database, extending file size, auto-grow. So as I said, yeah, you need to restart SQL Server. Here's just a couple of examples. Creating a 100 GB database, restoring a 100 GB database. Reduce the time by a factor of 5 and by a factor of 4. So if you don't use that, just remember it's not switched on in your VM. You need to go switch it on, and it's well worth doing. OK. What else affects disk performance? I mentioned the disk warm-up. I just wanted to do a reminder of that, though. It's just really useful to know this if you're doing your baselining, capturing your deltas. You don't want these numbers to be going all over the place. Warm up the disk first so you get consistent readings. So do work to the disk. The NTFS allocation unit size, sometimes that makes a difference. The default is 4K, I believe, and our tests have found that default is fine in a VM. So this is really there to say you probably don't need to actually tweak that in an Azure VM. We've heard some people, particularly earlier when the rate of IOPS was a bit more variable or was a bit more of a mystical property, people were trying to use multiple storage accounts to maximize their IOPS. Generally, we don't recommend doing this. For one reason, your data in different blobs, there's no guarantee of write order. So if you then got a database and using multiple storage accounts, you could have consistency issues and recoverability issues. So for that reason, it's not really recommended. Your blobs can start going out of sync if you have a stripe set composed of multiple storage accounts. If they're completely separate databases, and maybe that's a different matter. Instead, it's worth just spreading the load across multiple VHDs. Instead of, in other words, use file groups, use SQL Server-based striping, as I mentioned. It's also worth noting that a storage account itself has an upper limit of 20,000 transactions per second. And that's what people are trying to get past when they use multiple storage accounts. OK, well, I'm pretty much near the end now. I'm just going to kind of recap some of the things that we went through. As I said, I'll try and sell the white paper, the free white paper. Definitely worth reading. We went through some of the ways to plan and test. Keep in mind the performance variability. Definitely test for that and check how that affects your ultimate application performance. Identify your optimal VM size. That's perhaps the most significant thing. I mean, if you know the performance characteristics on-premise and you're migrating and you know what size to put it in, then you've done most of the work already. Optimized for reduced I/O. There's several ways you can do that. And also consider if there's any way you can change your actual application architecture to reduce network round trips. If you're using multiple data disks, use file groups for striping. Figure out which are your key performance indicators and keep monitoring them over time. These things will change, hopefully generally get better. They refresh the architecture. Things do change. It's really good to keep track of that. And also as your workload grows, revisit those optimization decisions. The last thing I've included in this deck, so if you download the deck, a lot of the references and resources I used going through this, as well as the white paper. There's several things on just SQL in infrastructure as server basics, just the basic architecture, some in-depth articles on Windows Azure storage, and then some of your traditional SQL Server performance white papers, really good papers on like analyzing I/O characteristics that work in any environment. Even TempDB I/O best practices, that's actually a blog entry. I think it's by Kaylin Delaney. And then another good white paper that was released fairly recently, maybe last year, was Performance and Scalability Compared and Contrasted. This was for Azure SQL DB and SQL Server. So this is like what we called SQL Azure. Then if you go revisit any of these TechEd sessions, I captured the ones that are perhaps the most relevant. So that's pretty much it. Any questions on any of that? Hopefully, I've given a few things you can walk away with. Yeah. Yeah, maybe more, actually. Maybe like 16.
Yeah. So, when I've researched that, people say, oh, same number of cores you have. What's your philosophy there?
In that particular example, there was one core. Having said that, it was a very artificial example because it was a workload designed to really pound TempDB. So you can't always say the number of cores. It is workload specific. So number of cores didn't matter in this case. It definitely massively improved performance because we were just pounding this poor single file. So.
One question. The 2.1 number, does that correspond to?
So I believe it corresponds to, you can look it up, but I believe it corresponds to a TFS page. Sorry, a PFS page, this page-free space page. So I don't know if it's specific to TempDB. I think it's just really indicating that it's those page-free space pages that are being affected. But, yeah? Yeah. Because in this case, it didn't matter, because the overall IOPS that the application was driving was less than 500. If we needed more than 500, then yes, definitely, I should have spread it across multiple drives. But I just didn't need to in this case. But it's a good point. Yes?
Yeah, have you played with any of the SQL 2014 hackathon type stuff?
Yeah. In fact, we're having a question and answer session, a panel discussion at 1 o'clock. I don't know if any of you are planning to go, but I'm hoping to get all of the people with all of this expertise in the same room. Hackathon has definitely been some work being done. It works really good in the high memory instances. So yeah, they've been testing that, and the results are really, really looking good. Yes.
The instance
Great question. Why isn't it enabled by default, you might ask? What it is, I think, is there's a potential security concern. I don't actually think it is, because our CSS tend to recommend it, and they're really paranoid about things like that. But if you don't do that file initialization first, then if you are able to go and look at those raw disk sectors, you'll see whatever was on them before. And I think that's why it's not switched on by default. As long as you've got control over your system, it's not an issue for most people. But I believe that's why, yeah, you have to go switch it on yourself. You have to kind of accept that. But yeah, that's a good question. OK, well, do let me know any comments. Fill in a survey, and I'd really like to know what I could do better, what you liked, what you didn't like. It will really help me. Other than that, thanks a lot for coming. Appreciate it.